for that end of the year test, which one is greater? 5, because we were adding. Here, 2.5, we would say A, because 5 is bigger than 2, right? And a half. 5 is greater. If you wanted to write that word out, you could. So that end of the year packet, or that end of the year final is coming up. You could start working on I-15 in your workbook at any time. I-15 is the review for the final. That is going to be that last day. Today, I-7 packet. If you didn't finish yours, you thought, oh crap, I had to turn it in early yesterday, you can come in during advice. We are going to analyze brick thickness. We actually aren't going to do the experiments as I mentioned. So I can make a scatter plot. You're going to still make those scatter plots, setting your scale. I can describe a pattern when I look at that scatter plot. Meaning, does it have a cluster, like a bunch of dots grouped together? Does it have an outlier, something that doesn't fit? Is it a positive or negative correlation? And is it linear, nonlinear? So those are all the things that we always want to think about with this unit. Can I describe the pattern of the data in terms of the situation? Do I think it is linear? Oh, if it's linear, could I write a trend line? Can I interpret the y-intercept? Like, where is that y-intercept? And I can use an equation with the trend line to summarize the data regarding additional points. So many bridges are built, if we continue reading this, with steel beams. Steel is very strong. Any beam that will bend or break, we want to put through a weight test. So if you think about this, the amount of weight that a beam can support is its thickness is going to be based on the thickness of it, the length, and the design. So to design a bridge, engineers need to understand these relationships. Engineers use scale models when they are doing this. Today, we are going to be making models to test how our bridges strengthen. And like I said, we actually aren't going to strengthen this. This year in science, did you guys do some things with holding weights, like making different items and trying to see how much weight it could hold as you were doing throughout? Sometimes you had triangular things, other times you're looking at different things in your lab. So what we have done in the past is we've started with this strip of paper. Like I said, I was cleaning out all my files and stuff a few weeks ago, and the last couple of years we didn't get to this, last year or the year before, obviously we weren't in school. So what we did was we put it in between two books, we made a strip of paper, we put a cup on there, we kept adding pennies. We kept doing that over and over, okay? What I want you to take a look at is on the top now of page 17. And on the top of page 17, it looks like this. Those of you that didn't have yours, please write down layers, breaking weight. With layers, you're going to put X, so you're going to write this on your paper. X, Y, you're going to make layers, put 1, 2, 3, 4, 5, those of you that aren't having your notes, and the breaking weight. I also want you, most of you, if you look at your table or your graph, it does not have this on the bottom. So please write layers. And where each dot is, go across and write 0, 1, 2, 3, 4, 5, 6, 7, 8. Right? So you're going to have the 0 first. And then going up, each tick mark is going to be 5, 10, 15. Please do that now. But on average, from years past, the first layer, the paper folded at 9 pennies. Okay? We put 2 layers of paper. We started with 2 fresh pieces of paper. The paper then broke at 16. After 3 layers, it actually held 24. And 4 layers held 34 pennies on average. And 5 layers of that paper in between the 2 books held about 42. So we now want to plot that. We don't have anything at 0, so we'll up from 1 and go to 9, a little below 10, right? Go up from 2 and plot 16, a little above your 15, okay? Plot 324 on your graph. Now, here's the one thing that I really noticed when I was looking at yours. After you plot the points, we would want to draw a straight line with that ruler. But what I noticed on a lot of your I-7 is that whatever these numbers went up by, saw people right here. So they would put 9, 16, 20. No, that's not constant. You can't do that, okay? Mathematically, I mean, obviously, not all your points are going to be there, but no, you have to set a scale. You have to go, oh, my data went from 9 to 42. I need to make sure I go up to 45, right? A little more than 42. And I have to set that scale. So I might divide and go, oh, I go up by 3s or 4s or 5s as I'm looking at this, okay? So, in years past, like I said, when everyone's done this experiment, this is kind of where people have ended up. Some of your graphs are off a little, but generally, most people's look like this. If you didn't draw that line, please draw that line. And as you look at this, the next question down in your notes on the bottom of page 17 says, okay, so we're looking at this. What is the pattern? Would you say as the number of layers, so when we think about our patterns on the test next week, when you describe the pattern, you're going to say, as the number of layers of our bridge, right? The number of layers increases, what's happening? Jack. The weight that it holds, or the weight also increases. We're talking about the weight of pennies that it holds. That's just a general statement. That's the kind of stuff I'm going to be asking you to make for me. As the layers increase, and when you always make those statements, what you're looking at is you are always looking at how does my X change? As the layers increase, what happened to my body weight or the breaking weight? So when you think of that I-7, if you're going to be working on that, that's the kind of statement that I was looking for. So now look at your table, and how do we think it's changing? From 9 to 16, 16 to 24. So 9 to 16, I'm adding about how much? 7. 16 to 24, I'm going to be adding a little more, right? I'm adding 8. 24 to 34, I'm adding 10. 34 to 42, 8. Could I find the average of those? Yes. Could I look at my graph and go, you know what? I think as I go over 1, what's my rate of change? I went up to 9, maybe 8.5, right? So what could I use for my slope? Remember, slope, if you write down right below this table, is rise over run. Slope is also the change in y over the change in x. I can see my x's are always changing by 1. I can see that my run is 1. What I have to decide is, do I want to find the average of these numbers, or do I want to just look at this graph and go, I went up 9, right? That's my rise. I went up 9 and over 1. And is that the case almost here? Yeah, it's a little less, but that could be up 9 and over 1. Up 9, right? If we are going to count that, and over 1 would be about here. So I would take, when you give your equations, you can estimate, right? So what if someone says, I think it's about 8.5x? I take that answer. What if someone else said, you know what, Mrs. Thompson, on mine, y equals 9x? I take that answer. That's why the I-7 is kind of hard to grade, because all of you drew your lines a little different as I'm looking at those equations. So it says, okay, now this is the part on the I-7 that some of you really struggled with. It says, well, how many pennies would you have for a breaking of 14 layers? Remember, we're going to use this equation. The y is the weight. That's our pennies, right? The x is the layers of paper, okay? So, layers of paper, as I am looking at this. Channing, what do you think I should have x or y equal 14? Which one? The weight or the layers? So I'm gonna say x equals 14, and I'm gonna write, I like this equation, it's just a little easier. On your paper, please write down y equals 9 times 14. Take out those calculators. 9 times 14, did you do?
Yep.
And you got how many?
126.
126. 126 pennies. Would someone have a different answer if they would have used 8.5 times 14? Yeah. It'd probably be a little less than that, right? So I want you to notice that we might put this approximate. If you used an equal, put approximate. Why? Because what if it held 127 or 124, right? Because if you're putting those pennies in that cup, it could keep holding more, and someone could be a little more, a little less, okay? We're going to have an approximate. On the test on Friday, the next question is going to say, okay, or next week, how many layers would hold 300 pennies? Well, 14 holds 126. We know it has to be more than 14. Is this 300, Jason, when you look at it, the Y or the X? It's the Y. It's our number of pennies, right? So we're going to put Y equals 300. This is the one that's a little trickier for some of you to do. So I'm going to go still, I'm going to use this equation. Y equals 9x. Except I'm not replacing x, I'm replacing the y. 300 equals 9 times x. If I'm going to solve it, Jamie, what are you thinking of doing? Divide both by 9. Those of you that have your calculators out, help me out. Zach, what are we thinking? Approximately, how many layers? 33 layers. Paper. Right? Does that make sense to everyone as we are kind of taking a look at that? If you turn way back to page 47 and 48. As you start this assignment, I just want to give you a couple pieces of information that I think are going to be helpful for you as you are looking at this. The biggest thing for me is that when I have students make the table. So please, with layers, call that your X. Put your length in feet is going to be Y. So please put out in front X and Y. On the next page, on page 48, put the width is X, the length is Y. And those of you that didn't have your textbook or your workbook, I will get you, print this out for you in just a minute. The next thing you are going to do is, as you take a look at this first part, we want to put our label down here. You're going to put your label. What do we think I should be looking at, Jack? This is going to be layers. The layers are going to go by 0, 1, 2, 3, 4, right? 5, 6. Over here is going to be your breaking weight. Now, look at this one, how high it goes. It goes from 12 up to 61. So maybe when I'm looking at the breaking weight, and it tells us we're talking about pennies, so we might want to put that breaking weight. This is how many pennies it holds. We are going to be looking at maybe going up by tens, because we got to get up to 60. So 10, 20, this is going to be my 30. Do you have to write down every single number? That's up to you. I need you to turn to the next one. This one really kind of gives people problems on page 48. Again, people don't have a problem setting it up. They go, oh, I'm going to go with, and this is where you really need your calculator. And this is going to be length. When I read the problem, Jack Runful, you're on this page, or on 48, because this is where people are struggling with it. But I have a rectangle whose area is 300 feet, square feet. The length is 20 and the width is 15. Finish the table below in terms of 10 possible rectangle areas. Hint, the numbers have to multiply to 13, or to 300. So, if I have 15 and 20, could I say, okay, now I think the width is 20, what would the length be? If I know 15 times 20 gives me 300, now of course I have 20 and that's a different point, right, on this graph? Because the first one went over 15 and up 20, the second one, okay? I can have a lot of numbers up to 300, right? I wouldn't go more than half. So like the biggest number I might have is maybe my length is 150. What does the width have to be? The key thing, area equals length times width. And we said our length and width have to be equal to 300. So if I know the width, or I know the length, I'm going to take 300, and if I divide by 150, what do I get? 2. You have to make this table, and could you pick a decimal if you want? Sure. I would go anywhere from 2 up to about, for those lengths, anywhere up to 150. Like I'd have maybe 150 as one of them. So 2 to 150, and I'm going to pick a bunch of numbers. I'm just going to keep checking on my calculator that I divide to get the other number. So if you pick 10, and you can pick different numbers. What does that mean for the length here? I have to go from 0 to 150. So again, I might go up by 10, 20, 30, 40, 50, 60, 70, 80, 90, 120, 40, yeah, 150. If I'm looking at that, I might want to go maybe by 15, right, instead of 10. So you can set that scale. The scale is probably going to be the same on both.